by 2 mv squared minus 1 by 2 mu squared, which was the initial and final kinetic energy. Right? From your topic, you have the last concept of this chapter, that is power. See, power and energy, they are quite related things. However, we observe that work and energy, they are equivalent, but power represents how fast energy can be consumed or how fast work can be done. Okay. So you can define power as the rate of doing work. It defines how fast the work can be done. Okay. So power, it is defined as the rate of doing work. Rate of doing work is called power. Okay. So how fast someone is doing any work, that we call as the power. For example, consider a fat person and a thin person. Both of them, they are running. Okay. So the fat person will generally run slower, but the thin person can run faster. Okay. So within a given, if suppose both of them are supposed to run a distance of 200 meters, so both of them, they are doing almost the same amount of work, but the thin person will complete that work in a smaller interval of time. So therefore, a larger power is expanded by the thinner person. Okay. So power is basically how fast one is doing some work, how fast something is consuming the energy. And we define power as the rate of doing work. So rate of doing work is called power. Okay, so how fast a person works, that is called as the power. That is the rate of doing work. Okay. Now, how we define this? We can write this power as work done per unit time. That is what the definition says. By the definitions, we have the same meaning. Power is work upon time. Okay, rate of doing work, how fast the work is being done. Okay, so work done divided by time is called as the power, and SI unit for this. What can be the units of this power? So work done is generally measured in joule and time is measured in second. So your SI unit of power is going to be joule per second. Okay. Or you can also write it something like this as joule second minus 1. Okay. The same unit, joule second minus 1 or joule per second, it is also called as watt. So remember, watt is the SI unit of power. Okay. So this is the SI unit of power, which we say that watt, and we have also used it. We also use it every day in our life. For example, you use a bulb. You say the bulb consumes the power 8 watt or 100 watt. Suppose if you are using a refrigerator, so you say the refrigerator consumes a power of 350 watt. Okay. So all the devices, they have a power rating. Power rating means how fast they are consuming the energy or how fast they are doing the work, that is called as power. Okay. So what is power? It is the rate of doing work. Work done by time is called as power, and its SI unit is watt. Okay. Now if I want, okay. So if I want, what would be 1 watt? When I can say that a substance has a power of 1 watt. ठीक से कम से कम दुनिया का दुनिया का ठीक से कम दुनिया ठीक से कम You see. Now, if I define this, what is 1 watt? So I can define 1 watt as if 1 joule of work is done, 1 joule of work is done in 1 second. If 1 joule of work is done in 1 second, then power of the device, then power is said to be 1 volt. Okay. So when we say that the power is 1 watt, if 1 joule of the energy is consumed or if 1 joule of the work is done in 1 second, then we say that the power consumed by the device is 1 watt. Understood this? Now in the similar way, this is the SI unit. This is the SI unit of power. Apart from SI unit, we have certain other units of power. And those other units of power, they are horsepower or HP. This is a commonly used unit. This is generally a common unit. Like for the measurement of mass, you have a unit of kilogram, you have pound, you have certain other units also. But kilogram is the SI unit and pound is the other system of units, FPS system of unit. So in the similar way, horsepower is another commonly used unit. You might have heard many people saying that the engine of the car is of this much HP. It has a power of this much of HP. So that HP means the horsepower. It represents the horsepower. So in the olden times, a horse was considered to be very powerful. Okay. So therefore, horsepower was used to measure the power. Now I can see that all the cameras of everyone are off except Siddhisri. Only Siddhisri camera is on. All of you turn on your cameras. Harini, Neil, Chavan,
Yes.
everyone turn on the camera. Harini, Chavan, turn on the
Yes.
camera. Yeah, all the cameras should be on. You can use such decorative filters like Chavan is using, but your camera should be on. Okay. So HP stands for horsepower. Fine. The horsepower, it was generally supposed to be the power of 1 horse. And if we compare this 1 HP or 1 horsepower to the SI system of units, so we have this conversion factor as 1 horsepower is equivalent to 746 watt. Okay. So 1 HP or 1 horsepower is equal to 746 watt. Understood this? No doubts here? Okay. So let us see. Let us try to understand this with one of the examples. We see one of the questions and try to solve this. Compute the power in those cases. Let's see. Work, energy, and power. Okay, let's see. Okay, rate of doing work. Let's see. So here you have a question. Example 11.7, as you can observe. We will try to understand this. I will solve this problem. You just need to observe what are the things given Okay, if you can get it already, you can start solving. See, so you have the problem says two girls, each of weight 400 Newton, climb up a rope through a height of 8 meter. We name one of the girls A and the other B. Girl A takes 20 seconds while B takes 50 seconds to accomplish this task. What is the power expended by each girl? Okay. So let us see, draw the diagram, understand what happens. So you have two ropes. You have two ropes, each of height 8 meter. So two ropes are there, which are of height 8 meter. And there are two girls. You have girl A and girl B. So the girl A and girl B, they are trying to climb up this rope. Let this be girl A, let this be girl B, and they are trying to climb up the rope. Okay. Each of weight 400 Newton. So girl A, it weighs 400 Newton, and the girl B weighs 400 Newton. So first of all, tell me, is this 400 Newton? What is this 400 Newton? Is this mass? Is this weight? Or is this a force?
It is the weight.
It is the weight, and weight is also equal to the gravitational force. Remember the definition of weight. The weight is equal to the gravitational force. The weight of an object, it represents the force with which gravity pulls an object. So therefore, this force or the weight of the object which is given, it also represents the gravitational force acting on A and B. So A and B both are experiencing the same force, 400 Newton, and hence to move in the upward direction. If these girls want to move in the upward direction, so they must use a force of 400 Newton only. They should both use a force of 400 Newton. So A should apply a force of 400 Newton. B should also apply a force of 400 Newton. Okay. I will tell you the same thing in other way also. Okay. So they have to apply a force of 400 Newton and they have to cover a displacement of 8 meters. Right. So we can calculate the amount of work done as force into displacement. The force is 400 Newton and displacement is 8 meters. This is same for both the girls. Both the girls, they have to apply a force of 400 Newton. They have to climb up a displacement of 8 meter. So if you multiply, you get 3200 joule of energy which is being expended by them, or the work done by them is equal to 3200 joule. Okay. Now we can compute the power by the formula work by time. So work over here is 3200 joule divided by time, and the time here is given as girl A takes 20 seconds and girl B takes 50 seconds. So first of all, I want to find out the power of girl A. The power of girl A will be given by 3200 divided by 20, and as you can see, this is equal to 160 watt. Similarly, the power expended by the girl B will be 3200 divided by time, which is 50. So in this case, you get your answer as 64 watt. So which girl uses more power, girl A or girl B?
Girl A.
Yeah, girl A uses more power. She has more power, that is 160 watt. And the girl B uses less power, that is only 64 watt. Now the same thing, whatever we have done by using the concept of work, the same thing we can also find out by using the concept of energy. Okay, as work and energy, they are equivalent. So we can observe that when the girl is at point A, she moves to the point B on the top. So therefore, potential energy gained by the girl A, potential energy is given by the formula mgh, right? So you can also compute the potential energy that will be equal to the work done, and hence you can obtain the answer which will be the same thing. Okay, so mg represents the weight, which is 400, and multiply by the height, that's 8, and you get the same answer as 3200. Right? So any doubt to anyone? Yeah, any doubts to anyone? No. Okay, so let's do another question, and now you will be doing that question. Okay, so see, question number 3. See here, now we want to do these questions. First of all, you try question number 3. Try question number 3. Let's see if you are able to get the answer. A lamp consumes 1000 joule of electrical energy in 10 seconds. What is its power?
The 100 watts.
100 watt, right? So the answer is, Siddharth, did you get the answer?
Yes, sir.
Okay. So your answer is 100 watt. Just by using the formula of power is equal to work by time or energy by time. So energy is 1000, 1000 divided by time, which is 10. So this is equal to 100 watt. Okay. So these things we have already discussed. So Chavan, can you tell me what is power? How do we define power?
mgh.
No, how do we define power? Neil, how do we define power?
Sir, by the formula.
See here, we have already defined. How have we defined power?
Doing work. Yeah. The
Rate
rate
of
of doing work.
work.
Rate of doing work, right? Power is defined as the rate of doing work. Okay, so see, we define power as rate of doing work. Okay, so Siddhisri, what is the formula of power? Siddhisri, formula of power. Siddhisri, am I audible?
Yes,
Yeah.
sir.
Okay, what is the formula of power?
Sir, actually, I forgot.
Yeah.
I was not Sir, actually, I forgot, sir.
You forgot. Okay. So you have the formula here. You can see. See the formula and tell where you have the formula of power.
Sir, P is equals to W by T.
Yeah. And what is W?
Uh, work.
Yeah. W is work. Very good. And what is T?
T is time.
Time. Very good. Okay.
Sir, what is P, sir?
P stands for power.
Power. Okay, sir.
Okay. So P stands for power, W for work, and T for time. Okay. The same formula can be written like this also. Power is equal to energy by time.
Okay, sir.
As work and energy, they are equivalent. So you can also call it as energy by time. Okay. Now let's see a few more questions. Uh, see. This question. Let's see. Okay. As you can observe the question, a boy of mass 50 kilogram runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, find his power. Okay. So again, we can use either concept, like we can use the concept of work, or we can use the concept of potential energy. Suppose this is your ground floor, and from the ground floor, the boy is running something like this upstairs, okay, with the number of stairs being 45. Okay. So in this way, suppose he is running like this, and over here, up to this point, when he is reaching, there are 45 steps. Okay, there are 45 steps, and each step is 15 centimeters. So here you can assume that this step is 15 centimeter each step. So again, this step is also 15 centimeter. Okay. And time that he takes, time taken is equal to 9 seconds. So time equal to 9 seconds, right? So let's solve. Try to solve this question. I'm waiting for your answers. Within 2 minutes, I'm waiting for your answers. I shall get the answers within 2 minutes. Take pen and paper and solve. Neil, start solving on pen paper.
Yes, sir.
You have two options to use. Either you can use the formula power is equal to work by time, or you can use the formula the same as energy by time. Both are same. Okay, so who has obtained the answer? Still, I have not got any answers. I think you people are confused. I
Sir, I
didn't get
sent
any
you,
answer.
sir.
No, I haven't got any of the answers. Yes, Rikshit has okay. I got from Rikshit, Orosmith. Fine. Rikshit and Orosmith, they have sent the answers. Okay. Rikshit, you sent it first to everyone.
Sir, by mistake, sir.
Okay. So I think everyone has obtained the answer. Let's check it out. How we are getting the answer and what is the actual answer. Okay. Siddharth, were you able to get the answer?
No,
Siddharth?
sir.
No. Okay. See, understanding it, this will require a little bit of understanding. Okay. See the
Sir, my
person,
answer correct?
yes, Harini?
Is my answer correct?
No, Harini, it's incorrect.
Uh-huh.
Okay, let's see. See, the boy is running upward. The boy is moving upward. Siddhisri, have you sent the answer? Siddhisri?
Sir, I did not got, sir.
Okay, so up to where you are able to understand, how much you are understanding? See, first of all, you have to compute the work done, okay, by using the formula force into displacement. Or if not this, you have to use the formula of energy. So what is the energy stored in the boy?
Sir, the kinetic energy one, right?
No, it's not the kinetic energy. Since he is running upward, so he is gaining potential energy, not the kinetic energy.
So which one will it be?
So his kinetic energy is given, his potential energy is given by the formula mgh.
Okay, I get. Sir,
Okay,
check if my answer is correct.
so his work done or his potential energy will be equal to mgh.
Oh,
He has a
oh,
mass
okay. I
of
did a
he
silly
has a
mistake.
mass of 50 kilogram. The value of g is 10, and the height over there will be 45 multiply 15 divided by 100, right?
Yeah. Okay.
So your this height will be 45 multiply 0.15.
Oh,
Right? Since if 15 is centimeter, so you need to convert this centimeter to meter. So multiply this 45 by 0.15, you get 6.75 meter. So height is 6.75 meter. Okay. So can you tell the amount of potential energy stored? Siddhisri? Siddhisri, can you tell the amount of potential energy stored?
Sir, instead of multiplying it now, can't we keep it so that we can cancel it at the end?
Okay. It can be possible. We can even keep it at up to end and then cancel it out. Okay. So you can either do like this, energy by time, that will be the power, and it will be equal to, energy will be equal to 50 multiply 10 and multiply height, which will be 45 multiply 0.15 and divided by time, which is 9. So you can cancel
So
9. You
45
will get,
into 9, right?
yeah, 45 and 9, they will cancel. You will have 5. Okay. So
Oh,
you
so
get
I thought it was 45, like I thought each step took 9 seconds.
no, no, no. The total time he is taking is 9 seconds.
Oh, okay.
Okay. It's taking a total time of 9 seconds. So now just multiply this, you will get the answer. So you will get 25 multiply 15 and that will be the answer. So 25 multiply 15 is 375. So power expended by the boy is 375 watt. Harini? Okay.
Oh, yes.
Not Harini. Siddhisri is there? Siddhisri?
Yes, sir.
Did you get this answer or did you get something else?
This only,
See,
sir.
first compute the work done or energy and then divide by time. Okay. Let's see another question. Now, before going to the next question, understand commercial unit of power. Commercial unit of energy, not of power. We need to understand commercial unit of energy. See, we have an SI unit of energy, right? What is the SI unit of energy, Siddhisri? Siddhisri, what is the SI unit?
Sir, can you repeat?
What is the SI unit of energy?
Sir, SI unit of energy is, I think, watt, right? No. Joules, right?
Joule. Joule is the SI unit of energy.
Not watt. Watt is
Kilowatt.
the SI unit of power, right?
Yeah, what is the SI
Okay,
unit
yeah.
of power? And
And joules.
Joule is the SI unit of energy. Okay. Now here, why do we need a commercial unit of energy? Do we purchase energy? Or Smith, do we purchase energy anytime?
Yes, sir.
Yeah, we do purchase energy. When? Can you give any example when we purchase energy?
So electricity.
Electricity, of course, when we are paying bills for the electricity, so we are paying for the energy that we have consumed. We are paying for how much energy we are consuming, right? So over there, we require commercial unit of energy. Why we require the commercial units? As the non-commercial unit, which is the SI unit joule, it's very small. If you are running just one bulb every day, so then also if you calculate for 1 month, for 1 month, the energy consumed will be equal to crores of joules. Okay, and we do not want those things to happen, crores and crores of joules of energy just by consuming one bulb. Okay, so we want a suitable unit, and that we call as the commercial unit of energy, which is kilowatt hour. So kilowatt hour is the commercial unit of energy. It is also called as unit. Just it's also called by the name unit. Like you might have heard your parents saying that we have consumed 200 units of electricity.
Sir,
Okay. So those 200 units of energy that have, yes,
sir,
those
how many
units of
kilowatts
energy,
is
they
a
represent
joule?
kilowatt hour. Okay, we will just see how many kilowatt is joule. How many, not kilowatt, how many kilowatt hour. Okay, so for we have the formula of power given by energy by time, right? The formula of power is energy by time. If you multiply this power by time, then we are going to get energy. Okay. So if we have energy as power into time. Now, if I want energy in kilowatt hour, so for that power should be measured in kilowatt and time should be measured in hour. Then we get the energy in kilowatt hour. Okay, so this is a very important formula we will be using to find out energy consumed in commercial units by taking the power in kilowatt and time in hour. Okay, so your power will be in kilowatt. Suppose if you have your whatever power you have in watt, you need to divide that by 1000 to convert it to kilowatt. Okay, so this is the basic thing which you require up to here. Now, as Chavan's question is how many joules are there in 1 kilowatt hour? So you can simply convert this as 1 kilowatt will be equal to 1000 watt, and 1 hour is equal to 3600 joule of energy, and then you can multiply them. You get 3, 6, and then 5 zeros. Right? So this much joule of energy is there in 1 kilowatt hour. You can convert it to the standard form, which will be 3.6 times 10 to the power 6 joule. So this is your answer. Yeah, Chavan. So have you understood 1 kilowatt hour is equal to how many joule? Yeah, Chavan, have you understood
Yes,
how
sir.
many kilowatt hour is equal to 1 joule? So 3.6 into 10 to the power 6 joule are equivalent to 1 kilowatt hour. But we will see we will solve one of the problems just now. Let's say where we will be using the commercial unit. So see this question now. Okay, see. You have an electric bulb. See, an electric bulb of 60 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the bulb. So in 1 day, how many joules of energy is consumed by the bulb? We have it here. So use the formula. I'm giving you the formula. Compute the energy. Okay. I'm giving you all the directions. You just need to tell me the answer. Energy will be calculated by the formula power into time, and you have to take your power in kilowatt. If you want your answer in units, so you have to take your power in kilowatt and time in hour. Now let's see who obtains the answer. And this time I am expecting answer from Siddhisri and Siddharth. You have not provided any answers. Okay, I have already got answer from Chavan Kaushik. I think this time he's correct. Oro Smith has given answer, but certainly this is not correct. Oro Smith, convert your power to kilowatt. Oro Smith, you have taken your power in watt. Convert it to kilowatt first.
Okay, sir.
By divide, convert it to kilowatt, you will get your answer.
Sir,
Yes?
this is this new lesson, sir.
No, this is from work and energy, not new lesson.
Sir,
From work.
I was out of station, sir.
Okay, so at least you know the power formula of energy. I have
Yes,
written here. The formula of energy is written in front of you. Okay. The power is given here 60 watt. Time is also given 6 hour. Just use it. You will get the answer. Just inject the values at their place. You will get the answer. No, Siddharth. Okay, let's see. See, power is given in watt. You have been given here, see. Power is 60 watt. Okay. So power is 60 watt. How can I convert to kilowatt?
By
Siddharth,
1000.
divide by 1000?
0.06.
So divide by 1000. This 0 gets cancelled. And you write 6. There are 2 zeros in the denominator. So you have 0.06 kilowatt. Okay. So you have got the power in kilowatt. You know the time in hour. So put the values here. You get the energy. Energy will be power into time. Power is 0.06 multiply time, that's 6. You have to take your time in hour only, not in second. So you will get your answer 0.36 kilowatt hour or units. This is your 0.36 unit. Okay. So shall we try one more question now?
Yes.
Siddharth, are you getting? Yes. When we talk of commercial unit, it's kilowatt hour. Okay. If it's not commercial unit, so it will be joule. So you see here, the answer is 0.36 unit. Okay, let's see. Okay, see this question. And now try to do this. I'm writing the formula here for your help. The energy will be given by power into time. And that's it. So try doing this. See, this way I think you will get this time.
Sir, do we have to do it in kilowatt again?
Yeah, again you have to take it in kilowatt. You have to tell your answer in kilowatt hour. Okay. So I think someone has sent the answer. Chavan Kaushik has sent the answer. Okay, that is correct. Siddharth, just check it once. You have to convert your power into kilowatt and time should be in hour. Take your power in kilowatt and time in hour.
Send the answer.
Oro Smith, yes, your answer is correct. Siddharth's answer is also correct now. And let's see who all are sending the answers. Siddhisri, I think you have not got the answer? Harini?
No, sir.
Sir, I
Okay.
sent the answer to you.
Harini. Neil has not sent the answer. Yeah, Harini, your answer is also correct.
Okay, sir.
Okay. See, this is just you need to inject the values. Just inject the values in proper units. Okay, Harini, Siddhisri, what does P stand for?
Value.
No, what does this P stand for?
P. Power.
Power.
Huh.
What? So, in this question, what is power? Power is 1500 watt. The symbol W is for watt, and watt is the unit of power. So, in that way, we can identify that this 1500 watt is power. Okay. So, now can you do this? Convert this power to kilowatt. You are given power as 1500 watt. Convert it to kilowatt. So, this will be 1500 divided by 1000. Okay. So, you will get 1.5 kilowatt. Okay. Just put the values over here. In place of power, what shall we write, Siddhisri? One 1.5 and multiplied time is 10. So 1.5 into 10, that will be 15 kilowatt hour or 15 joule of energy. So 15 joule of energy is consumed by the heater. Okay. So no, not 15 joule, it's 15 units. My mistake, it's 15 units. We have 15 units of energy is consumed there. Okay. So I think today we have done a number of questions on the commercial units. We have done a number of questions on power also. So I hope you have understood this topic of power. Okay. Let's do a few questions overall from energy conservation. Let's try to understand energy conservation in few examples. So, okay, Siddharth, what do you mean by energy conservation?
Saving energy.
What it means? Saving
Saving
energy.
energy.
No, it is not saving energy. Energy conservation means you cannot destroy energy. Okay. It means that energy cannot be destroyed or it cannot be created. It can just change from one form to the other. Like in one of the classes, we had discussed about energy transformation. So do you people remember the class where we had discussed about energy transformation? Energy transformation means energy can change from one form to the other. If someone is cycling, so the chemical energy stored in the form of food in his body is getting converted to kinetic energy. Okay. So energy is just getting changed from one form to the other. We also learnt about the electric fan. The electric fan uses electrical energy and converts it to mechanical energy. Okay. So in everyday life, we observe that energy can neither be created nor be destroyed. It can just change from one form to the other. Okay. So this is called as energy conservation. Now we will try to understand the similar thing using a simple pendulum. So who has seen a simple pendulum? Is there anyone who has seen a simple pendulum?
Yes, sir.
Okay. See, a simple pendulum, it consists of a thread, a metal bob, just this thing, a thread and a metal bob, which is fixed to a point, and this metal bob is allowed to oscillate between two extreme points. Okay. So this is a metal bob, this is extreme point A, this is extreme point B. The ball is taken to this point A, from there it is released, so it starts oscillating between these 2 points. Okay, so you have already learnt about this in class 7 about the pendulum, but here we will talk of pendulum in terms of energy conservation. Okay, so yeah, I think we shall continue with the next class. In the next class, we will see about this, about the energy transformation that is occurring during a pendulum, or energy transformation that occurs during a roller coaster. So bye everyone.
Thank you, sir. Bye, sir.
Bye, sir.
Bye.
Yes, sir.